Hey there, are you studying Maths A-level and heading into Year 13 this September? Are you ready and wanting to take your Maths A-level skills to the next level and kickstart an amazing Year 13 of success in Maths? If the answer is a resounding yes, then you've come to the right place. Welcome to our A-level Maths Summer Transition video. In this video, we'll be diving into some fantastic worked through examples which cover all of the three math skills which are examined, as 50% of the exam will ask you to apply routine learnt procedures, but then 25% will require you to interpret, make deductions about your maths, and the other 25%, which is the most tricky part, asks you to problem solve by putting a situation in a mathematical context and apply your knowledge. So this video will be full of valuable tips that will help you stay ahead of the game during the summer break. By mastering these concepts, you'll not only be super prepared for Year 13, but also give your UCAS predicted grade a powerful boost. So let's get started. All the questions are examination examples and they will challenge your mind. Keep those Year 12 skills sharp. From calculus to algebra, we have got it covered, and we'll even add some new skills too. But here's the best part, we won't just solve these, we'll break them down step by step so you can grasp the underlying concepts with ease. Remember, understanding the why behind the maths is just as important as getting the answer correct. So all the questions are time-stamped in the description, and you'll also find a link there to download a file with all the questions. A good idea would be to pause the video, have a go, and then watch the explained solution, giving you some key insights and problem solving strategies, because Year 13 maths, here we come. You'll be able to impress your classmates and teachers when you return to school. So whether you're aiming to improve your UCAS grade or just love immersing yourselves in some maths, this video is for you. So enough of the chit chat, let's get started. Don't forget to like and subscribe and share this video with your maths loving friends. So starting off with something that's not too difficult, this is just asking you to use routine procedures that you should have learnt in Year 12 or possibly even GCSE. So a line passing through 2 points. So I would maybe draw them out. We've got A at 3, 1. And we've got B at 4, -2. And we're trying to find the line that passes through those 2 points. So to find an equation of a line, we need an M, a gradient, and we need a point. Well, we've actually got 2 points. I would maybe use point A because both coordinates are positive. It's easier to deal with them. We just need a gradient. So we need a change in Y over a change in X. I can see that here, vertically, the change in Y is 3. Here, horizontally, the change in X is 1. It's sloping downhill, so rise over run. Y over X is going to be 3 over 1, and it's sloping down, so it's minus. Then we could use Y equals mx plus c, but at A level you tend to use y minus y1 is equal to m into x minus x1. So now we can just feed in what the x1 and y1 are, because that's using our point, and we know what m is. M is going to be minus 3. So it's going to be y minus 1, because that's our y1, is equal to minus 3 x minus 3. It's our x1. So y minus 1 is equal to minus 3x, and then minus 3 times minus 3 is going to be plus 9. At A level, we usually take everything over to one side, so it's going to be 3x plus y minus 10 is equal to 0. In this next question, we're just again applying some routine procedures. We should have learned how to find the gradient of a curve by doing some differentiation. So we can see the shape of this curve, because it's quadratic, is going to be like this. It's going to have a negative gradient before it gets to its minimum, where the gradient is 0, and then when it slopes back up, the gradient will be positive. So the gradient is always changing, and how do we find the gradient at a particular point? We're going to put 5 in to the expression we get when we differentiate. And to differentiate, you have to do dy by dx, which is a procedure which gives us an expression to put the 5 in, and that will tell us the gradient at that particular point. So how do we differentiate? Well, you have to take the power down. So power down, that 2 is going to come down times by the 2 on the front, and then we take 1 off. So you times by the old power and take 1 off. So that's going to be 4x. Now when you're finding the gradient, if you think about minus 12x, if you think about y equals mx plus c, if we're interested in the gradient, it's just the number in front of the x term. So here the minus 12x just goes to minus 12. If we use the rules for differentiation, it's minus 12x to the 1, and you just power down, so that 1 times the minus 12 would be minus 12. If we take 1 off the power, x would be x to the 0, and anything to the 0 is 1. So it's still going to be 4x minus 12. And then if you think of the 16 as 16x to the 0, when you power down, numbers just go out. And if you think of y equals mx plus c, if we just had a plus 16, if we had the line y equals 16, that would just be a horizontal line at 16 that doesn't actually have any gradient. So numbers on the end are just going to go out. Now all we need to do is substitute in the fact that we want the gradient at x equals 5. So when x is equal to 5, dy by dx is going to be 4 times 5 minus 12, which is 20, minus 12, which is 8. So at the point 5, 6, so somewhere up here in the curve, the gradient, the slope of the curve will be 8. In this next question, we're again just looking at routine procedures, and it's vectors this time. So we're given position vector A and position vector B and asked to find the vector journey A to B. So because we are told that that is their position, we draw them out. A is at 3 minus 7 and B is at 8, 3. Now we can draw them like that because we are told that they are position vectors. That is from a common origin, and we want to find the journey from A to B. So whenever you're asked to find the journey A to B and we have A and B both given in terms of that common origin, what you need to do is go back down A, which is minus A this way, and then up to B. So A to B, whenever A and B both come from a common origin, is minus A plus B, but we can write that as B minus A. So B is going to be, in terms of the column vector, 8, 3 minus A, 3 minus 7. I like to work in columns, so you can just do the i's is on the top, so that's 8 minus 3, 5i, and then 3 minus 7 is plus 10j. So that is the vector A to B. It's going to be 5i plus 10j. In part B, we're asked to find the magnitude. Those modulus lines means the size of it. So we can see that to go from A to B, we would have to go 5i and then 10j. And we want to find the length of this line going from A to B. So we're just going to use Pythagoras. It's going to be A to B is equal to 5 squared plus 10 squared, which is the square root of 125. It's asking us to give it in simplified third form. So 125 is 25 times 5. So this is going to be 5 root 5. This next question is asking us to use the factor theorem, and we're being asked to show that. So it's not a formal proof, but when we're asked to show things, we should have some statements. So using the factor theorem, so the factor theorem tells us that if x minus 3 is a factor, then f of 3 is equal to 0. Now, why does that happen? If it's a factor, then it can divide in exactly. So x minus 3, if it multiplies by some expression which is going to be a quadratic, because when we divide this linear term into this cubic, we're going to have here a 4x squared in order to get that term there. So we can see those two times together is going to give me this cubic. So those two times together gives me back the cubic that I've started with. And if x is equal to 3, then this bracket equals 0. When it times us by that quadratic, it's still going to equal 0. So those two times together give me this cubic, and that cubic will have to equal 0. So let's put f of 3 in. So it's going to be 4 times 3 cubed, which is 27, minus 12 times 3 squared, which is 9, plus 2 lots of 3, 6, and minus another 6. So those 6's will cancel. 12 times 9 is 108. 4 times 27, well, if we times the 4 by 3 and divide that by 3, that's the same as the 12 times 9, so that comes to 108 as well, or it's just double 54. So it's going to be 108 minus 108 plus 6 minus 6, it does actually equal 0. So this tells us that x minus 3 is a factor. Now in part B, hence show that 3 is the only real root. So x equals 3 is a root, but how do we find the other ones? We'd have to actually do the algebraic long division. So dividing it in. Now we've got that 0, we know it's a factor, so we know we're going to get 0 remainder when we do the algebraic division. So let's take this first term. X into this is going to go 4x squared. When you get an answer on the top, multiply it by both the terms on the front. You're always going to get back that same term, and then we're going to have minus 12x squared. Take away to get the remainder. Now we can see that's going to go out, those first two terms are going to cancel, and we're just going to get the 2x minus 6, bringing that down, and then divide again, you're going to get plus 2, multiply that 2 by everything on the front, you're going to get 2x minus 6, so we are going to get the 0. So x minus 3 multiplied by the 4x squared plus 2 does equal now the cubic that we had to start with. 2x minus 6. So x equals 3 is one of the roots. Now what about this quadratic here? We can take a factor of 2 out, and then it'll be 2x squared plus 1. So if that was to have any real roots, then 2x squared would equal minus 1, x squared was equal minus a half, and you can't take the square root of the negative, so there's no real roots from the quadratic. So x equals 3 is the only real root. Okay, question 5, we're doing some integration here. We're given this function f of x, and we're told that when we integrate it between the limits 1 and 2 root 2, we get the answer 16 plus 3 root 2. So we've got to show that. So all we need to do is do the integration and end up with that answer. So if we're going to integrate this between 1 and 2 root 2, I'm going to write it in 2x plus 3. Now I'm going to write this term here because I can't integrate when that x term's in the denominator, so I'm going to write it as 12x to the minus 2. And then we need the dx. So now let's do the integration. Once you do the integration, you integrate into big square brackets. Everything's going to go up by a power, so you add 1 onto the power and divide by that new power. So 2x is going to be 2x squared over 2. The 3 is just going to go to 3x. Then we're going to get plus 12x to the minus 1 over that new power minus 1. And then we're going between 1 and 2 root 2. So the limits, once you've integrated, go on the other end of the big square brackets. So let's tidy that up. These 2's will cancel. We're going to get x squared plus 3x. And then here, this minus 1 will make this sign minus. The 12 is going to stay on the top and the x is going to go on the bottom. Better to put this term back into that form, because once we're going to sub these limits in, we want to be subbing them in with that x on the bottom. So now we sub in the top limit. If we want to square 2 root 2, so it's going to be 2 root 2 all squared plus 3 lots of 2 root 2 minus 12 over 2 root 2. And then put the 1 in. We're going to get 1 plus 3 minus 12. So 2 root 2 squared, I need to square the 2, which is 4, and square the root 2, which is 2, and 4 times 2 is going to give me 8. And then here, the 3 times the 2 is 6 root 2. Here with the 12, we're going to get 6, and I've got 6 over root 2, which I would rationalize the denominator, so times top and bottom by root 2 over root 2, which in effect just times it by 1, so leaves the value of this alone. But then that rationalizes the denominator. I've got 6 root 2 on the top, and then root 2 times itself is 2, so altogether that is 3 root 2. So it's minus 3 root 2. And then here we've got 1 plus 3, which is 4. 4 minus 12 is going to be minus 8. So this minus into the bracket is going to give me my 16, which is good because that's what I want. And then I've got 6 root 2 minus 3 root 2, which is plus 3 root 2. So I've shown that that integration does equal the answer. So that is the question done. Question 6 is asking us to prove from first principles. So I've put what you get in the formula sheet here. You get the first principles formulae. And what's going on here, the f dash is the same as dy by dx. It's just the function notation. And it's the limit as h tends towards 0 of f of x plus h minus f of x all over this h. So what's going on here is, say we've got a function, let's just draw it like this, doesn't really matter what it is. This is x, and then instead of calling this y, this is the y coordinate when we put x into the function, so we can write it as f of x. If we go a bit further along the function, say x plus h, where this distance here is h, then this point here is x plus h and f of x plus h. So when we take them away on the top here, you're just really finding the difference in the y coordinates, and h is the difference of the x coordinates. Now what's happening as this h tends towards 0, then these points are getting closer together when it's actually 0 that's on top of each other, and you're just finding the gradient at that single point, because remember, gradient is the rise, the difference in the y over the run, the difference in the x. So that's all you're doing. So what we need to do is write f dash x is equal to the lim as h tends towards 0 of f of x plus h minus f of x all over h. Now you have to just keep writing this out and just sub the things in. So f of x plus h, if the function is 3x squared, this is going to be 3 of x plus h all squared, and then minus 3x squared all over h. Now multiplying out that bracket, we get 3 into x squared plus 2xh plus h squared minus 3x squared all over h. Tidying up and putting the 3 in, so you're going to get 3x squared plus 6xh plus 3h squared minus 3x all over h. Now these 3x squareds are going to cancel. So we've just got the lim as h tends towards 0 of 6xh plus 3h squared over h. Now I can take h out as a factor, 6x plus 3h all over h, and cancel that. So I've got the lim as h tends towards 0 of 6x plus 3h. Now as h tends towards 0, so as h tends towards 0, 3h tends towards 0, so the whole thing is actually just equal to 6x. So f dash x is equal to 6x. Question 7 is on the binomial expansion, and I've written here what you get on the formula sheet. So notice when we're expanding two terms to the n, in our case it's going to be to the 7, you get this expansion here. Now each term in the expansion has 3 parts. So we just take the second term here. You've always got an NCR part. So this bracket notation stands for the NCR, which you're going to press the NCR button on your calculator. It has an a to a power and a b to a power. So notice that we start with the a to the highest power on the bracket, and the powers on the a's go down and the powers on the b's go up. So each term has 3 parts. So if we were looking at this second term here, you've got NC1, a to the n minus 1 and b to the 1. So this number at the bottom of the NCR button is always the power on the b, and these 2 powers sum to the n. So this first term here is really NC0, which is equal to 1, a to the highest power n, and then b to the 0. So b to the 0 is also 1, so these 2 we don't really write, it's just going to be a to the n. Similarly, on this last term, you've got NCn, which is equal to 1, a to the 0, which is also equal to 1, and then b to the n. So some pupils like to write them going down the way rather than writing them across, so that you just make sure you've got each of the 3 parts and you just follow that pattern. Okay, let's try and apply the binomial expansion to our question. So for part A, we've got our A is equal to 2, our B is equal to minus x over 2, including that sign, and n is equal to 7. So it's going to be 2 to the power of 7 plus 7c1 times 2 to the 6, and then the minus x over 2 to the 1, plus 7c2 times 2 to the power 5, and then minus x over 2 all squared. Because this second term is just not a single term, it's got that 2 on the bottom, putting that in brackets and making sure that when you square it, you need to square the denominator as well. So tidying up, 2 to the 7 is 128. Anything C1 is just the anything, so this is just going to be 7. 2 to the 6 is 64, and then we've got our minus x over 2. 7C2 is 21 times 32, and then minus x all squared will just be x squared. This minus squared will cancel, and we've got the 4 on the bottom. So carrying on to tidy up, we've got 128 minus 224x, and then plus 168x squared. So that's part A, just asking us for the first 3 terms. Now, whatever the power is on the bracket, there is always one more term. So if we were going to carry on to complete the whole of the expansion, there would be 8 terms. Okay, we're only asked for the first 3, so on to part B. Explain how you would use your expansion to estimate the value of 1.995 to the 7. So we've just been dealing with an expression to the 7, and now we've just got this number, but it's to the 7. So if we let the 2 minus x over 2 equal the 1.995 because they're both being raised to the 7, and then just rearrange and solve for that x. That x is what we're going to substitute here into our expansion to find an estimate. It will be an estimate because we've only got the first 3 terms. So just rearranging and swapping these to the other side, you've got 2 minus 1.995 is equal to x over 2. 2 over minus 1.995 gives us 1 over 200 is equal to x over 2. Cross multiplying, and we'll see that x has to be 0.01. So what we need to do to find an estimate is to sub in x is equal to 0.01 to give an estimate as only have 3 terms. So if we had all of the 8 terms, it would give it as an exact value. So what we could do is do 128 minus 224 times 0.01 plus 168 times 0.01 squared. Now if you do that on your calculators, it comes out to be 125.7768. Now if we actually do on our calculators the full value of 1.995 to the 7, so 1.995 to the 7 comes out to be 125.7767. So we can see that we have got a very good estimate even just using the first 3 terms. Question 8 is asking us to calculate the area of this lawn given the 2 angles in the triangle and this length along the base. So when we're looking for the area of a lawn, we've not got a right angle triangle or can't find any perpendicular height. So we're going to be looking to use half AB sine C, and this works where we've got 2 sides and an included angle. So we need to find either this side or this side. Now we're going to do that by using the sine rule. We can work out that this angle here is going to be 50 because angles in a triangle add up to 180, and then we've got a pair of opposites and we can find whatever. So I think I'll go for this side here. So I'm trying to find BC, and it's going to be that length over sine 70 is equal to 30 over sine 50. Now just rearranging, this gives me that BC is going to be 36.8, and then I have side angle side, which I can feed into this formula here. So the area is going to be half times the 36.8 times the 30 times the sine of the angle in between them, which is 60, and that comes out to be 478.05, and we're in meters and we're finding an area, so it is meters squared. So it's asking us to 3 significant figures, so that's going to be 478 meters squared. Now in part B, why is your answer unlikely to be accurate to the nearest square meter? So this is asking us to imply our knowledge and interpret our answer. So it's strand 2, make some deductions about what we've got. We've got an answer of 478. So here we notice that all the information in the question is given to one significant figure. So all values are 1SF. So we can only really presume that our answers are accurate to one significant figure. Really, to get an answer that's accurate to 3 significant figure, the information in the question need to be to 1 more degree of accuracy. So need 4SF as info in the question to get accurate answer to 3SF. So that's kind of a rule of thumb, that you need the information in the question to be 1 more degree of accuracy, and then you can say that your answer is to 1 behind the amount of degrees in the question, the given information. So the other thing is that we've got a triangle here that's representing a triangular lawn, and it's modeling the fact that the lawn is flat on the ground. It's two-dimensional, whereas we know in real life that a piece of lawn is not going to be flat. So that's maybe another reason why it's not going to be accurate, because it might not be flat. Question 9 is asking us to solve a trig equation, and we can see we've got sine squared and cos, and the idea here is to get the whole equation just in terms of one ratio. So we can't substitute anything for the cos, but we can use the identity sine squared x plus cos squared x is equal to 1, rearrange for sine squared x, which is 1 minus cos squared x, and then we're going to sub that in here for that, and then everything will be in terms of cos. So it's going to be 12 into 1 minus cos squared x plus the 7 cos x minus 13 is equal to 0. Now I want to set it up so that I have my quadratic term positive, and I can see when I multiply this 12 in, it's going to give me minus. So I need to multiply that 12 in and take everything to the other side. So I'll have a 0 on this side. I'll have 12 cos squared x. Now let's set it up so it's going to be easier to factorize. So we've got our quadratic term, then we've got our minus 7 cos x on the other side, and on this side we're going to have plus 12 but minus 13, so that'll be minus 1. When we take that to the side, it will be plus 1. So factorizing this, if I have 4 cos x and 3 cos x, that's going to give me a 12 cos squared, but then I need to have plus 1, so we need a 1 and a 1. This is telling me signs need to be the same, but negatives are involved. So if I have a minus minus, that will give me the plus 1. When I multiply these outers, I'm going to get minus 4x minus 3x with the inners is going to give me that minus 7x there. So 4 cos x minus 1 is equal to 0, or 3 cos x minus 1 is equal to 0. Rearranging for cos x will be a quarter, or cos x will be a third. And then on our calculators, getting a principal angle, inverse cos of a quarter is x is equal to 75.5. And then inverse cos of a third is x is equal to 70.5, so 1 decimal place. Now it wants answers in the range 360 to 540. Now normally we have answers in the range 0 to 360. So 0 to 360, your cos graph goes like that, but we need to go another 180 because we want answers between 360 and 540. Now our calculator has given us answers here before 90 of our 75.5 and 70.5. So what we need to do is just add 360 on, and then we will be here. So 70.5 plus 360 is going to give us here x is equal to 430.5. And then the 75.5 plus 360 is going to give us 435.5. So these are going to be our answers that are in the range. Now in this next question, question 10, we're being told that this equation in terms of k, we want a k which has no real roots. We're being asked to prove that for that to happen, k has to be bigger or equal. So you have to be sharp at noticing this one's equal to, but this is strictly less than. So as soon as we're seeing the word proof, we can be aware that we have to be making deductions, so using that strand 2 and also using that strand 3, putting this situation into a mathematical context and applying some maths. So this question has got all three aspects of what is being examined. You've got to do some routine procedures, you've got to deduct and interpret, and you've got to apply some maths to this particular question because of that word proof. So we've got a quadratic equal to 0. We've got to find the k when it has no real roots. Well, as soon as you see the word roots, you're going to be thinking b squared minus 4ac has to be less than 0. Because what is b squared minus 4ac? That is the discriminant, and it's the part in the quadratic formula which gives you the two answers. So when we're solving the quadratic formula, you get x equals minus b plus or minus the square root of that discriminant all over 2a. So the plus or minus, and when we add on the square root of the discriminant, that gives us the two answers. So when the discriminant is positive, you're going to be taking the square root of a positive, which you can do, and you will get two answers. When that discriminant is 0, you're only going to get one answer, and the answer will be the minus b over 2a. When that discriminant is negative, you're not going to get any answers, there's no solution, and that means that the graph, if it's a positive quadratic, will be strictly above the x-axis, and there's going to be no roots. Roots are where the quadratic is going to cross the x-axis. So that's the routine procedure that we're going to be applying. But so let's apply that and then have a look at this part of this inequality. So we're going to be writing b squared minus 4ac has to be less than 0 for no real roots. So when you're being asked to prove, like, write out a statement. So what is a, b and c? A is the k, the coefficient in front of x squared. B is 4k and C is 3. So we're doing b squared, so that means we need to square all of b. So be careful when b is just not a single term, it's made up of 4k, you need to square the 4 and the k. So that will be 16k squared minus 4 times a, which is k, times c, which is 3. So let's tidy that up. 16k squared minus 12k is less than 0. Now when you're solving a quadratic inequality, this here, what we've got is an inequality that's come from the discriminant. It's nothing to do with the actual quadratic that we've been working with, but it can be solved in its own right. And what we need to do is look for where this one has its roots. So if we factorize and take 4k out, we'll have 4k minus 3 has to be less than 0. And think of where this quadratic equals 0. So 4k into 4k minus 3 equals 0 when k is equal to 0 or k is equal to 3/4. So if we were to plot this quadratic, we'd be drawing this bit here, and we want the part where we want it to be less than 0. So we want between 0 k and 3/4. That's where the graph goes under, and that's what we want it to do, to be less than 0. But noticing here that we've got it equal to 0. So by applying the discriminant and solving that quadratic inequality, we've only just proved that k has to lie between 0 and 3/4. So we have to notice that we've got it equal to as well. So what happens in this original quadratic? When k is equal to 0, you're going to get 0x squared plus 4 times 0, 0x. You're going to get 3 is equal to 0. So that can't happen. So this is going to tell us that more than just this inequality. So as when k is equal to 0, no real roots either, because this situation, the 3 can't equal the 0, so 0 less than or equal to k less than or equal to 3/4. So this was worth 4 marks, and if you didn't do that extra bit there about the inequality, you only got 3 of the marks. Now we're getting to the latter part of this paper that we're working through. I've put here the exam information about what strand is being examined. So strand 2 is when we're interpreting, we're constructing mathematical arguments, making deductions and inferences, and explain our reasons. So you're getting all the marks here, 3 marks for all strand 2 work. It's question 11 in this paper out of 17 questions. Now it's asking us to prove for all positive values of x and y this statement here. Now we don't know what's going on here, so what we can do is just try and manipulate this to try and see if we can find some statements that we can make that are true, and then see where that takes us. So I don't really like this 2 underneath, so I'm going to multiply and cross multiply and take that 2 up. So I'm going to get 2 root xy is less than or equal to x plus y. Then I'm just going to square both sides. 4xy is less than or equal to squaring all of the right. It will be all squared. Multiply out that bracket. See where that takes me. X squared plus 2xy plus y squared. Now, when I'm dealing with quadratics, it's nice to have everything to one side and equal to 0, and that will give us something to sort of make a statement about. So 0 is less than or equal to x squared minus 2xy plus y squared. Now when I multiplied out this bracket, because it was plus here in the all squared bracket, I got plus. Recognizing that now I've got minus, I can factorize that. It's going to be x minus y all squared would give me back that. Now, because I've got a statement that anything squared is going to be above 0, this holds true for all x and y. It would actually hold true for positive or negative x and y's. So we've done all this working, but what you've got to do when you do a proof is end up with this statement, and we kind of use that to start the working. So now we can see what's going on. We need to rework it, is what they're looking for, so that we end up with this as our final line. So prove that for all positive x and y. So for all positive x and y, let's make a statement. 0 is less than x minus y all squared. Anything squared is positive or above 0, or 0. So making a statement about what we're doing, and then we just need to work backwards up from this. So 0 is less than or equal to, squaring that out, x squared minus 2xy plus y squared. Then we need to add 4xy to both sides. 4xy is less than or equal to x squared plus 2xy plus y squared. And then we need to factorize the right. So that will be x plus y all squared. Then we need to take the square roots. This would be 2 root xy has to be less than or equal to x plus y. And then root xy is less than or equal to x plus y all over 2. So we've ended up with what we were trying to prove. So that is what we need to do. So we can say hence, and then we've got that there, what we're trying to end up with. So that would be the proof. You do need to end up with proving what you're being asked as your final line. In part B, prove by a counterexample that this is not true when x and y are both negative. Well, all you need to do this is sub in, say, x's, think of some negative numbers, -3, and y equals -5. Just put some negative numbers in. Counterexample just means we need to have one example. So that would give me the root of 15. Is that less than or equal to -8 over 2? Root 15, is that less than or equal to -4? No. not true. So this provides a counterexample to say that it's not true. Question 12 on this paper, and again I've put the exam information about what strand is being examined. When we've got strand 1, we're just carrying out routine procedures, but strand 2, we're constructing arguments and we're assessing the validity of those arguments. So what we've got here is a pupil's working, and we've got to identify some errors. So we've got this equation here, which they've just written down again, but what's happened in line 2, because we've got these powers that are being added, then it should be 2 to the 2x times 2 to the 4, because the rules of indices would then, we would have to add them, but they've got an add. So line 2 is wrong. So minus 9, 2 to the x equals 0. That's what it should be. So line 2 should be 2 to the 2x times 2 to the 4, not 2 to the 2x plus 2 to the 4. So that's where they've made an error. And then letting 2 to the x equal y, that's a good thing to do because we've essentially got a disguised quadratic. So when we've got 2 to the 2x, that is in fact 2 to the x all squared, and if we're letting 2 to the x equal y, that should be y squared. Then minus 9 2 to the x is minus 9, but this 8 in line 1 2 3 4, this 8 they've presumed 2 to the 4 is equal to the 8. So line 4, 2 to the 4 is 16 and not 8. But they've done it wrong anyway, because 2 to the 4 being 16, and because this is a times, that really should go on the front. So we should really have 16y squared minus 9y is equal to 0. There shouldn't be any number on the end. So that's what we should be doing. So we've identified the two mistakes, and now solving the equation. Well, we're already at this stage. Here we would just factorize, take y out. So that would be 16y minus 9 is equal to 0. So y is equal to 0, or y is equal to 9 over 16. So that's telling us that 2 to the x is equal to 0, or 2 to the x is equal to 9 over 16. Now if you think of 2 to the x, so it's going to be a graph like that, that's never going to be 0, so that's a non-solution. And then if we go down here, 2 to the x is equal to 9 over 16. If I just think of my log rules, then I could just do log to base 2 of 9 over 16 is equal to x. So I always remember 4 cubed is equal to 64. Another way to write that is log to base 4 of 64 is equal to 3. So the answer to the log is always the power. 4 cubed is equal to 64. 2 to the x is equal to the 9 over 16. So that is our answer to the equation. In this next question, again, I've got the exam information. We have got 5 marks for doing strand 1, which is routine procedures, but then we've got some strand 3 where we're putting things into mathematical context and translating the problems so we can do and apply mathematical processes, and we're going to interpret solutions and put them back into the original context. And I'm going to be doing that in part C when we're looking at this plus A. So first of all, let's have a look at part A. Exam speak when you're asked to factorize completely is usually a clue that there's 2 steps. So we can see in this expression here, x appears in each of the terms. So if we take x out as a common factor, we're going to have x squared plus 10x plus 25. And then factorising completely, the second step is going to be factorising this quadratic, because that factorises to x plus 5, x plus 5. So we've got a repeated bracket, x into x plus 5 all squared. So in part B, we're asked to sketch the curve showing the points where it intersects with the x-axis. So when we've got it in the multiplied out form, we can see it is a positive cubic, so the shape's going to be up, wiggle up, with the tails going in the opposite directions. And then when we've got the factorized form, we've got two things. If we say equal to 0, that will find our roots, and two things timesing together, either x is equal to 0 or x is equal to minus 5. Now, because we've got this repeated bracket, then the minus 5 is going to be where the graph is a tangent. So let's draw the graph with the axes. We're going to have minus 5 and 0. Now, because it's going to be this shape and we want to have the roots where it goes through, we're going to have a tangent here. So it just sits because we've got our repeated bracket, and then it's going to go through the origin there. So that's all we need for our sketch. And then having a look at part C. Part C says there's a coordinate minus 3, 0 lies on a curve with this new equation. Now, when it says here, translate and put things in their original context, you've got to always be on the lookout for when you're given some further parts in the question that relate back to the original. And I can see the original is something cubed, 10 something squared, and 25 something. Got the same here, something cubed, 10 of the something, and 25 of the something. The only difference is, instead of having x, I'm now doing x plus a. So you should recognize this as x plus a is going to be a transformation of graphs. So there are 6 types and they come in pairs, and when you've got a plus on the inside, that is going to go the way you don't think. It's going to affect the x coordinates, and x plus a is going to translate it a to the left. Now, this is telling us that the graph with this equation that relates to our original graph, which we've already got as a sketch in part B, now goes through here at minus 3. So because we've done left or right with this plus a in the brackets, it's either going to be 2 to the right or 3 to the left. So what's going to move that is when we've got x. 3 to the left will be a plus 3 in the brackets, or 2 to the right would be x minus 2. So whatever the sign is here, it goes the opposite way. We want 2 to the right, so we need a minus 2 in the bracket. We want 3 to the left, so we need a plus 3. So a is going to either be minus 2 or a is equal to 3. So that is strand 3, and we are putting the translating what we're being asked about back to the original question from part A, and that is going to be strand 3, that's which is being examined. This next question is a modelling question. As soon as you're modelling a real life situation, you're going to be awarded marks from strand 3 when we're putting things in a mathematical context. And we can see here that we're modelling a town's population using this exponential model. I can see it's exponential because the t, the variable on the x-axis, is in the power position, and a and b are constants. But what we've got here is a straight line because we've taken logs. So if we write down the equation, p is equal to ab to the t. Now, taking logs to both sides, log of p is equal to log ab to the t, using the log law because these are times together to split them up with a plus, and then that would be log b to the t. And then using the other log law to bring that t down, we can say that log of p is equal to log of a plus t log of b. Now we can see that this is in the form of y is equal to mx plus C. Now the t is in the position of the variable. M is the log B, so that's why I've written them that way around so we can line them up of which one's which. And the log A is the y-axis intercept, which I can see is 5. So being asked to write down an equation for L, we can see the y-axis intercept is 5, and it tells us in the question that the gradient is 1 over 200. So we can say the equation of the straight line is going to be log to base 10 of p is equal to 5, the y-axis intercept, plus the gradient 1 over 200 t. So when you're told or asked to write something down, that's exam speak for which shouldn't be too much work. We should be able to just use what's in front of us and write it down. So that would be part A. In part B, find the value of A and B. So in our equation of straight line, the y-axis intercept is 5, and that from taking our logs to both sides is the same as log of A from our exponential model here. So we can say that log to base 10 of A is equal to 5. Now the answer to a log is always the power, so using the pattern 10 to the 5 is equal to A, so A is equal to 10 to the 5, which is 100,000. And then B, we can use the fact that we're told that the gradient is 1 over 200, and that's the same as log B from our equation of a straight line. So log to base 10 of B is equal to 1 over 200. Doing the same thing, 10 to the power 1 over 200 is equal to B. So B on our calculator is 10 to the 1 over 200, which that comes out to be 1.0116 or 1.013 SF. Right, part C, with reference to the model, interpret the A and B. So what's our model? P is equal to, now we've found what A is, 100,000 times 1.0116 to the t. Now, when we're looking at an exponential model, which would have this shape, you're looking through the y-axis intercept when t is equal to 0. This part of the equation will equal 1 when t is equal to 0. So that's telling us that the A, the number in front, is the initial population. So A is equal to 100,000, and that's the initial population. So at the start of this study, what we started with was 100,000 in this town, and then the constant B. Now if you think of when you are using multipliers to increase something, say I wanted to increase something by 5%, you would times by 1.05, putting that percentage of increase as a decimal. And this is what we're doing here, we're timesing by 1.0116. So the actual rate of increase is just this decimal thing. It's increasing at a rate of 1.16%, but the B is the whole of that multiplier. So B is proportional to the rate of increase. So it's not actually the rate of increase, because the rate of increase is 1.16%. Okay, part D, find the population predicted by this model when t is equal to 100. So D, part 1, all we need to do is P is going to be 100,000 times, now instead of using 1.0116, use the actual better unrounded value. It's going to be 10 to the 1 over 200 to the 100, because t is equal to 100. You put that in your calculator, that comes out to be the 316,227.766. It wants it to the nearest 100,000, so that's equal to 300,000. Part 2, the number of years it takes for it to reach 200,000. So this time the population needs to be 200,000 is equal to our 100,000 times 10 to the 1 over 200 to the t, and this time we've got to now work out the t. So if you divide by the 100,000, you're going to get 2 is equal to 10 to the 1 over 200 to the t. Taking logs to both sides, log of 2 is equal to t log of 10 to the 1 over 200. And then if you just divide the log 2 by the log 10 to the 1 over 200, t comes out to be 60.2 years. Now, the final part of the question, state 2 reasons why this might not be a realistic model. Well, because this straight line is just going to go on and on, it's predicting unlimited growth. It's going to go on forever and ever, and that's unlikely to happen in a town's population. There's always going to be something that's going to limit that growth, and also it doesn't take into account the fact that something might happen. If we're looking at 100 years, over 100 years, factors will come into play. There might be a disease that comes to this town, or there might be a war. It's not just going to increase in a linear straight line. Question 15, we've got these two curves, C1 which is a quadratic, C2 which is an ln curve, and we've got P which lies on C1 at a half 2. Now I can see the y-intercept for C1 is here 4, so 2's about here, so we've got this point here. Now we want the normal to C1 at the point P is going to meet C2 at Q. So if I draw a tangent here fairly steep, and we want a normal that's going to meet over here, and this is the point we want, Q. So what we need to do is find the equation of that normal and then equate it to C2. So the equation of the normal is going to have the negative reciprocal gradient to the curve at the point half 2. So what we need to do is do y is equal to 4x squared minus 6x plus 4 and differentiate to find the gradient of the curve at the point P. So that's going to be 8x minus 6, and then we want it at x equals a half. So the gradient m of tangent will be 8 times a half minus 6, so that's going to be 4 minus 6, which is minus 2. The m of the normal will therefore be a half. Now I've already got a point, so the equation of normal, we just need a gradient and a point. It's going to be y minus 2 is equal to a half x minus a half. Now normally I would go clear of fractions, but I want to make y the subject so that I can just equate that right hand side, the algebra side, to this. So I'm going to say y minus 2 is equal to half x minus a quarter. So y is equal to half x. Take the 2 to the other side. 2 minus a quarter is going to be plus 7 over 4. So now I need to equate that to the C2. So half x plus 7 over 4 is going to be Q when it meets half x plus the ln of 2x. Now I can see I can just take half x off both sides. 7 over 4 is the ln of 2x. E to the 7 over 4 will equal 2x. So x is equal to half e to the 7 over 4. Now all I need to do to find y is put that value of x in here to the y equation. So y will equal half of x, so that's going to be x, which is half e to the 7 over 4, plus the ln of 2 times x, which is half e to the 7 over 4. So that's going to be, or the y coordinate is going to be a quarter e to the 7 over 4 plus, now this 2 and this 2 will cancel. I'll just have ln to the e to the 7 over 4. The ln and the e's will cancel, so that'll just be plus 7 over 4. So the coordinates of Q is x half e to the 7 over 4. The y coordinate is a quarter e to the 7 over 4 plus 7 quarters. Question 16, just 2 questions left, and this is a modelling question. We've been given the plan of a swimming pool is this shape here, and we've got the dimensions. It's 2x across and y is these straight bits. We've got a semicircle and we're told that the area of the shape is 250. We're then in part A being asked to show that the perimeter. Now, a show that question is we're going to be applying mathematical arguments, interpreting the math that we are doing. So this is strand 2. In fact, of the 10 marks for this question, only 5 was routine procedures. The rest was the strand 2, interpreting the maths and then doing some problem solving. So we've got to get to this perimeter equation, and we can notice that it doesn't have any y's in it. So what we need to do, because we've been given that the area is 250, get the area in terms of x and y, but then have an equation that will be able to make y the subject, and then we can get a perimeter equation, and wherever we see y, substitute in. So the area of the shape is going to be 2xy for this rectangle here, plus the semicircle, and we can see that this distance here is also 2x, so the radius is just going to be x, and the area of a circle is pi r squared, so it will be pi x squared, but then over 2. So this is going to be plus pi x squared over 2, and we're told in the question that that's 250. So now we can take that x term to the side because we need to make y the subject, because we want to substitute that into the perimeter equation. And so y is going to be, dividing both of these terms by 2x, is going to be 250 over 2x minus pi x squared over, now this 2 and this 2 will times together to give me 4, and I'll have an x, and then that x will cancel, so that will be my y. Now the perimeter will be the 2x, the straight bit along here. We need 2 y's here plus 2y plus half a circumference. Circumference is 2 pi r, and r again is x, and we want half of that, so it's just going to be plus pi x. Okay, so now we need to do 2x plus 2. What was y? We need this, so it's 2 times 250 over 2x minus pi x over 4 plus the pi x. And now when we multiply this 2 in, we can see it's going to cancel here and reduce that 1 to 2. So that's that multiplied in. So the perimeter is 2x plus 250 over x minus pi x over 2, and then plus a pi x. So here we've got plus a whole pi x but minus half. So that's going to give us 2x plus 250 over x plus the pi x over 2. We've got a whole of something minus half of it is just going to give us half back. So that is part A. In part B, now usually this type of question, you are usually asked to find the max or min of whatever you've just worked out, and you might be doing some differentiation. But this in part B takes a little thinking about, because it's asking us to explain why x is sandwiched between, it's going to be bigger than 0 but less than the root of 500 over pi. We can see in our workings we've got a 250 over x, that might be something to do with it, but you know, this is not obvious where this comes from. Now what we need to do is look back at our y equation. So do be here, y is equal to 250 over 2x minus pi x over 4. Now for us to have a swimming pool, we've got to state that x is above 0 and y is above 0. X and y must be positive for us to have a swimming pool. So they're statements we can write down for the shape to exist. So if we go to this equation for y and make it as a single fraction, so I can do the common denominator is going to be 4x. So this one I need to multiply by 2. So that's going to be 500 minus, and then that one just needs to be pi x squared. Now for us to have a swimming pool, y has to be bigger than 0. So this is a statement for y which has to be above 0. Now for a fraction to be above 0, that's only going to happen when the numerator is going to be positive. We know that x is positive, so that's a positive on the bottom. I can cross multiply and take that up if you want to think of it that way. But this is only going to be positive when 500 minus pi x squared is above 0. Taking the pi x squared to the other side, 500 must be bigger than pi x squared. 500 over pi must be bigger than x squared. Now thinking about our x squared graph, because we're going to be taking the square root, we want it to be here. This will be minus 500 over pi and take the square root, and this will be plus 500 over pi square rooted. We want it the graph to be less, so we want in between here for the graph to be less, and we already know that x has to be bigger than 0. So overall x will have to be bigger than 0 but less than the square root of 500 over pi. Now having a look at part C for this question, we're asked to find the minimum perimeter. So to find max and mins, we have to do differentiation. So we're going to be doing dp by dx. So let's put the perimeter equation in a form where we can differentiate. So that x needs to come up. So it's going to be 2x plus 250x to the minus 1 plus pi x over 2. Differentiating, we've got 2, and then we're going to power down, so it's minus 250x to the minus 2 plus pi by 2. We want that to equal 0 for a min. So we do 2 plus pi over 2 is equal to, take that to the other side and do would be a plus 250, and then put the x to the minus 2 as x squared underneath. Make a common fraction, a single fraction, sorry, here with a common denominator. So that's going to be 4 plus pi over 2 is equal to 250 over x squared, and then we can cross multiply. So x squared is equal to 250 times 2 over 4 plus pi, which is 500 over 4 plus pi. So x is equal to, now we're just going to take the positive square root of 500 over 4 plus pi. Now we're not asked to determine whether this is a min. If we were asked to determine the nature and definitely make sure that it's a min, we do the second derivative, and if the second derivative at this value of x is bigger than 0, we've got a min. We're not asked to do that, so there'll be no extra marks. All we've got to do is now substitute this value of x into our p, and when you do that, you just have to be careful. I would put this in and then press equals. So on your calculator, it's the bottom of the right hand side in the screen, and then wherever you're seeing x in the perimeter equation, just type in that answer key in all those bits. And if you do that, it comes out to be 59.8, and we're going to be in meters. This is the last question, and it's a circles question. It was worth 10 marks, I think 7 of which are routine procedures, and then 3 software for interpreting what we're doing and problem solving. So we've got this circle which is centered at -2, 6 and it goes through the point 10, 11. Show that the same circle also passes through the point 10, 1. Now you don't have to, but I always like to draw a picture just so I can see what's going on. We've got the center at -2, 6. So here we've got our circle, so coming something like this. And if we say here and here are 10 along, and here 10, 11, and here 10, 1. So this is 11, and this here down here is 1. It's not drawn to scale, but it's enough to work with. So from the center we can go to the point that we know, and what we can do is try and find the length of that, which is going to give us the length of the radius. So if we see between the -2 and 10, we can see that horizontally this is 12, and between 11 and 6 it is vertically 5. Now if you know your Pythagorean triples, or you can just do some Pythagoras, 12 squared plus 5 squared and take the square root, then this comes out to be 13. So now we know what the radius is. So we can do our center and get the equation of the circle. So it's going to be x plus 2 all squared plus y minus 6 all squared is equal to r squared, 169, and we can just put the 10, 1 into this equation and show that it works, or we can go out to this radius, not drawn to scale, and show that again, horizontally this is 12 again, vertically going from 6 to 1, this is 5. So Pythagoras again tells us that that is 13. So the distances to the 2 points is 13. So that's another way to show that these 2 points do lie on the circle. Now in part B, we're being asked to show the distance between P and Q is 58. P is going to be when we've got a tangent to this point here, meeting the y-axis, so up here. So I carry on my y-axis, I want this point up here, and then if I do similarly and go down here where this one meets here at Q, I want the distance between the P and Q to be 58. So we need to find the equations of these tangents, have the tangents in y equals mx plus c, and then the c bit, the y-axis intercept, is going to be our P and our Q. So because we've already worked out what the distance here was, and we can look and use the same values to find the gradient. The gradient of this radius is 5 over 12, doing rise over run, and then the gradient of the tangent is going to be minus 12 over 5. Similarly, this radius here is going to be minus 5 over 12 because it's going downhill. So the m of this tangent is going to be 12 over 5 because we're using the fact that a radius meets tangent at 90 degrees. So what we need to do is find the equation of these tangents. So now we know the gradients and we've got the points, we can just do y minus y1, which is 11, is equal to minus 12 over 5 x minus 10. Y minus 11, take this in, is going to be minus 12 over 5x. When that minus 12 over 5 goes in, we're going to get a plus, but the 5 and 10 are going to cancel and give me 2, and 2 times 12 is 24. Now all we're interested in is that y-axis intercept, so we can just leave the minus 12 over 5. We're not bothered about the gradient. This minus 11 on the other side is going to give us plus 35. So that point there is 35. Now do the same with the other tangent. We've got again y minus 1 is equal to this time 12 over 5 x minus 10. So y minus 1 is 12 over 5x. When that goes in again, we're going to get the cancelling with a 2, but we've got minus, so it's going to be minus 24. Take the minus 1 over, y is equal to 12 over 5x. minus 23. So that point there at Q is minus 23. And then the vertical distance between those 2 points is just 35 plus 23. We can see just the sheer distance down there is 23. The distance up here is 35. So that's going to be 58. Thank you so much for watching. That was in fact the Edexcel Sample Assessment paper. I will put a link in the description to download the exam boards, how they divide it up into the 3 strands so you can see what an exam paper is made of, because this was the AS paper to help you in that summer between year 12 and 13. A lot of the content from year 12, so good to go through that over the summer. But when you do the actual A2 exam next year, it's the same rules. About 50% is going to be routine procedures, and then 25% for the other 2 strands. So hopefully you found that useful. Do like and subscribe. Keep an eye out on the channel for some more help for your Maths A level. Thank you very much. See you on the next one.